Okay, so you're lucky that this microphone's dead. It doesn't have battery. So no talking today. Probably I'm going to come to you with my microphone. If you see this blink, please let me know. If you see this light blinks, let me know so I can run and get a battery from the office. But for now, this is what we do. Please log into your computer if you just came in, because at any time we may do the quiz. You need to be on time on that. All right. So let's go to 244 notes. Okay, so we talked about references. That was it. Where are my code? I didn't write anything. Seriously? Okay. So yeah, so we have talked about references, understood what references are. I thought that I had something called crazy reference, didn't I? Where is the code then? Before that. So, oh yeah, you're right. So, function arguments, reference intro. Okay, good. So all we talked about last time was dynamic memory allocation and review of pointers. So today we have our work cut off. Okay, so good. So that's that. Any questions about dynamic memory allocation and pointers? I'm going to go through dynamic memory allocation again today. Okay, we're going to actually go through it and make sure everything is good and fine and dandy. So any questions on that? Dynamic memory allocation? Pointers? There are no questions on that in the quiz today. So that's going to be the next week when you are programming. You're going to do dynamic memory allocation, overloading, and things like that. Hello. Log in, please, to a computer. Okay. Yes.
In the workshop, we had a function, and that function starts with a compound type.
Mm-hmm.
Like,
Compound types? Yeah.
for example, it was a structure, pointer, and a function. It was a type of function.
Let's look at it. Yeah, we'll take a look at it. For now, I have trouble connecting for some reason to, let me see if Git is, I cannot bring up the notes. Huh. Anybody have problem going to the subject notes? Oh, it came up. It looks like Git is down, is it? Let me see. Okay, so you're talking about workshop 2, right?
Yes.
Overloading references. We talked about all these, right? Yeah. Dynamic memory of arrays. Working with compound types. Yeah. So you have a contact structure in DMA. Okay. See contact in DMA.h, which is essentially okay. So we have a struct contact. It has a name, last name, and a phone number, so it's a structure. Okay, so that's that. Now let's go back to, as you said, part 3. Get contact receives nothings and returns the address of a contact structures. Create a contact compound type. Dynamically gets and yada, 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 yada. Okay, and then the address of the contact structure is returned. No validation is done for the entry. Yeah, so essentially what I'm asking over there, say I have struct book, okay? And struct book has character title, say 31. And I have, oh, what's going on? Are we good?
Yes.
Okay. Size T, ISBN. I'm hearing people chatting. I hear people go, stop. Thank you. Well, that's very annoying. Okay. Sorry about that. Okay. Thank you. So I have, and then I want to write something called, so I want to have something that returns a book for me dynamically. So what I do, I write a book pointer. We know that. Get book. And all we need to do is to create a book over here. So book return is equal to new book, right? And then fill it in. As easy as that. So see out. And I said no validation required. So enter book title. And then I'll go cin, return, and m title. Cout, enter book ISBN, and cin, return ISBN, return ret. Done. Okay? So what you do over here, this returns a book dynamically. The only catch for it is that when you write something like this, you got to make sure that you delete that book after. So in main, in here, if I am creating a book pointer B, and I'm saying B is set to get book, okay, and say in here I have void display. Actually, let's do it like this. I'm going to say OStream reference display constant book reference B and OStream reference OSTR. And in here, OStream is cout. Cout is an object of type OStream. So actually, let me not confuse you. You'll see it soon. Void. I want to write fancy way, and then let me just not. Okay, so I'm going to say cout title b dot title cout ISBN b dot ISBN. So if I do something like this and I say display target of B, now I have to make sure I delete B. Again, you delete the way you delete the way you allocate. I allocate it as a single entity. I delete it as a single entity, right? If it was an array of books, then I had to delete an array of books. So I hope that explains. Okay? All right. So a dynamic compound type entry .cpp, something like that. Thank you. I like that. Ask questions like that. Any other question? Yes.
Should initiate the pointers as a node pointer.
That was a beautiful question. And the answer is, while you're a rookie, yes. Get used to it. So I deleted this because I know the program's ending. I didn't set b to null. But make it your habit for now to make the pointers you delete set to null. Make this a habit. Later on, when you can recognize and identify if you set it to null or not, then you delete it. Again, to be able to be a race driver, to go to a Formula One race, first you need to learn how to drive properly. When you learn the rules and understand how a car handles, then you know how to safely break the rules. That's what it is. So if you give this as your sample code to get hired someplace, they're going to say, what the heck? Person is setting the pointer to null when the program's ending. Why? Why you do that? There's no need. But for now, we want to have the muscle memory for it. Okay? Remember, so any pointer that is not used should be kept as null. Obviously, if you don't make it null over there, it doesn't matter. But it's a good idea for now. But 3, 4 weeks, 5 weeks from now, when you know why you are doing that. Why we are doing this? Why we set pointers to null? No, not really, really. No. So it doesn't point to garbage. Why? It's yeah, so it's like an open sign on a store. When you pass by, if the open sign is not on, the store is closed. You don't bother going there, right? It's just like that. You just said it that, hey, this is not pointing anywhere. Don't use it. Or you are free to put something in it because it's empty. You're just flagging it. This flagging is very important because you cannot recognize garbage number with a valid number. If you just leave it as a number, you don't know if it's garbage or not. The only way to flag something that, hey, this is garbage, it's not used, we call it safe empty state. You always keep your things in a safe empty state, which means you flag it with something to recognize that it's empty in future. And that's why we do that. And because there is no future for this, this was useless. I'm just doing it to get used to it. Okay? So in here, I'm going to say no need. No need. But good for a rookie to remember. That's something like that. All right? So there's no need. But yeah. Yeah. Anything else? Yeah.
We have 0 in this draw before deleting. Is it enough to put just in case of the character as 0, get rid of?
Oh, okay. So you're talking about null terminating strings.
I want to clear the memory.
You don't clear the memory. See, strings, how strings came to be in C language. In C language, we do not have anything called character. We know that. There is no such thing. The thing we call a character is actually a small integer, 1 byte integer, up to 256 if you go unsigned, or up to 127 and minus 128 if you go unsigned. So it's just an integer. But that integer is designed to be big enough to hold ASCII code of a character. Therefore, they wanted to show a word or a sentence. They created an array of these characters, and they put characters in it. Problem is that because it's an array, they don't know where it ends. So again, they came up with the flag scenario. They said, let's put the characters we need and make one after the last one an impossible ASCII code, which is 0, which is null. Mark it with that. Now, after that, you may have garbage. But because the standard is go and stop at null, nobody cares what's after. So you're not clearing anything. You're just telling to all the functions that are written for C strings that this is the end of data. Don't go further. So essentially, oh, this is not my computer. This is my computer. I'm like, where am I going? Okay, so let me just save this. So essentially what I'm saying is this. So when I do like this, what happens? It automatically adjusts the size of the array to the literal value that I'm putting in there, right? Now, if I go C out, obviously it's going to print for that Solimandlu, right? 3 years later, right? But if I write over here, again, the thingies are starting. Okay, if I say name, say 6, no, 4, 1, 3. If I say name 3 is, or 4, is 0, then I go C out name. It's not that I deleted the rest of it. It's just I brought the stop sign closer. Obviously, because we know what an array is, if I say C out address of name 5, it's going to print the rest of it to the end. Because it says I start and I go until I hit the null. So what you have after that still exists. I just put a stop sign halfway through. That's what strings are. String is just following a standard. That's one of the actually interview questions. If immediately when they're hiring you from C++ programming, they start with C questions to see how far they want to go. So the very first thing they're going to ask you is, what is a C string? So you have to immediately tell them it's a character array with a null termination. So essentially a null terminated array of characters. That's it. That's what a string is. And following that standard is string.h, or in C++, C string. C string is following that standard, which means when you do str copy, it copies until it hits the null. When you do string compare, and so on. So all the things that you do string, that's that. We good? No. It's you're like my mother. My mother said, how can I delete these pictures from Facebook? I'm like, you don't delete. You just let it go. Just don't look at it. Okay. She likes to clean everything up. Okay. So that's what it is. So you don't need to wipe it up. It's memory. No security. It's it's garbage. No, you don't need to. You don't need to clean things up. You just, yeah. It's like you just put the garbage under the rug and put the rug over it and be happy. You don't care that it's garbage underneath because it's covered with the rug. Okay? Got it? That's the thing. So you just block it. Don't let them see what's after. And nobody's going to look. Anybody ever came to your house and go, let me see what's under the rug? They don't do that, right? Unless it's your wife's. You want to see if you actually cleaned up properly or not. But anyway, so we're good? So remember, you just set a stop sign. Okay? Any other question? I like this session. Actually, questions are coming up. Maybe you don't want to do the quiz. That's why you're doing that. By the way, you know if you keep asking questions and I don't have time, you don't have a quiz? You know that, right? Because questions come first. Now everybody's thinking, what should I ask? How are your day today? Okay. Are we good? We didn't talk about memory resizing and stuff, did we? I don't think we did. We'll go through that. So for some reason, the notes are not coming up. That's sad. Let's try it one more time. I'm trying to bring up the notes. Here it comes. Hallelujah. Okay. So we are here, dynamic memory. Okay? And after this, we're going to accelerate. So all these things are going to happen in one session, probably some of it today. So be aware of it. I would actually like to have dynamic memory after this, but anyways, we're going to do it anyway. All right. So So how do we resize memory? How memory is being resized? So say I have a struct called name. All right? I have a struct called name. In that structure, I have a character pointer value, which value essentially says what the name is, right? Are we okay with this? Are we okay with this? So name carries the thing. Or let's make it a little juicier. So just going to write something like person, and I'm going to put over here name, and I'm going to put over here age. By the way, you know that that's the regulation that we follow. We put all, remember talking about encapsulation, putting the data and behavior together? We don't know how to stick the behavior in there yet, but remember any variable that goes inside a structure or a class, we call it a member variable. So C++ refers to it as member variable. But object orientation terminology calls that as an attribute. Remember that. Okay? So don't always call it member because that's C++. If you go to Python, it's not called member variable anymore. It's an attribute, remember. So, and that's object-oriented terminology all over the place. So if you say this is an attribute of the class, they know it's a variable inside a structure or a class. So this one has two member variables. And as you see, the member variable, the first one is a dynamic one, okay, which means I don't know what is the size of the name. I want to adjust it just right. So therefore, in here, I'm going to say init and I'm going to say person reference p. So I want to initialize a person. How do you initialize a person? I want to put it in a safe empty state. What is a safe empty state? I'm going to say p dot name is set to null ptr, and age p dot age is set to 0 because nobody has the age 0. You are at least, shoot, it's just born, it's 0. Is it 0? What do we call it? So design is not good. That doesn't have a safe. Actually, it does have a safe because they all come together. I will say if the name is null, the person is not there. So I can just remove that because it's a flag, right? It's not needed. So I'm going to initialize it that way. What counts is that. So if a person has a null for a name, it's an empty person. It's an unset person. So right off the bat, in here, I'm going to write void display constant person. Why am I making it a constant, by the way? If I don't make it a constant, it won't work. It will work, but it's not safe. Your worst enemy is programming is you. So you have to keep yourself safe from you, which means when the logic of when the name of the function dictates that the logic of this function indicates that no change is supposed to happen, to its argument, you must force it to do so. If you have your notes and you want somebody to copy it, do you want them to do something in it and then copy it? No, you just want to copy them, have a copy, and then do whatever they want to do with their copy, right? You don't want it to change. So taking a picture or Xerox of your note will not change your note. Therefore, you have to make sure that happens. If you pass a person by reference, you know that P becomes a new name for that person. Therefore, it's changeable inside the display. Not to change it by mistake, you always set it to constant reference. Yes, sir. Oh, okay. I thought there was a question on that. We haven't started yet, and you cannot do it on your own computer. It has to be on a lab computer. Okay? So you got to close your notebook when we are doing that. Just log into the thing. So that's that. So now in here, I can say over here, cout name and is but I will make it safe, which means if P dot M do this. Something like that. Now it becomes a safe thing. You follow what I'm doing now? So now in here, if I actually create a person, so if I say over here person, P, if I just print this, I don't know what's going to happen. Because I don't know if there's garbage in the name or not. So that's why I'm initializing it. So I'm going to say init P. That initializes P, makes it empty, makes sure everything is good. Now I can actually say display P. And I run this, it's going to tell me no data in person, right? Now we want to set the data in a person. So I can do another initialization. So another initialization that I'm going to do is not only initializes the person, but initializes the person to a constant character name and a size th. Okay? Because it's initialization, I am sure there is nothing in name. Okay? Because it's an initialization, I am sure there is nothing in the name. No resizing it's needed. It's brand new. So that's what why I am going to say this is equal to, and I am including C string. Soon you'll see we're not going to use C string anymore. I'll give you the C string that I wrote. You're going to add it in here because we don't want to have that stupid define CRT secure, no warnings at top of everything we are writing. Okay, so you're going to use either you're going to use your own C string because these are very simple functions. 2 seconds you can do it. It's just okay. Maybe it's a good practice if I actually do it now. I'll do it after. So name is equal to, now in here I'm going to say new character to the size of strlen of name. So our C, what is the length of the name, whatever name they want to set. I allocate that one plus 1 for the null. Plus 1 for the null. Oh, yeah, okay. Plus 1. If you don't add that one, this is the most common thing in segmentation fault, crashing your code. 1 here. Many people make a mistake and do this. Can anybody tell me what's going to happen? It's not going to give you an error. It's going to actually be 1 shorter. So if the string is 6 characters, it's going to give you 5 because you just say go 1 ahead. So you are advancing the array forward. Remember the question, the thing I wrote? I went halfway through my array and it printed the rest. If you do this, you're saying add 1 to the address, which means it's not going to count from the beginning of the array. It counts from the next one. So not only you're not adding 1, but you're shortening it by 1. So make sure you put the 1 out. That's another common mistake. And now this is an exact fit. I got a shoe that matches the foot perfectly. Now I'm going to say strcopy with no worries into mname, the name that is coming in. Oh, sorry, p.mname. We're good? Right? And now, after this copying thingy that I have done, I'm going to set p.mAge to the age that is coming in. Of course, I'm not doing any validation. So that's initialization. I'm initializing it. Now I can actually do this. I can actually, so this one was, so now I'm going to actually initialize it to Fred. And in here, I'm going to put, I don't know, 50. OK? So now if I run the program, what's going to happen? Oh, build errors. Woohoo! Let's see what our build errors over here. Yeah, CRT secure. Yeah, remember I told you I hate those things. It's going to happen? That's what I was talking about. Where is that thing? I should be able to go to right. Can I? Oh, there you go. I always forget how to spell that, so I always copy and bring it up. That's why I never learn. Okay, so define. Okay, so now when I run this program, it's going to say Fred is 50 years old, right? Are we okay? Now, can anybody tell me if there's anything wrong with this program? You just got 1% for midterm. 1% for midterm. I did not deallocate. This program had Fred, that's 5 Fred, and 1 null, that's 5. So 5 bytes memory leak. I didn't delete it. Because I didn't delete it, it's going to be in the computer until I reboot it. It's not going to go away. Obviously, in Visual Studio, because it's an integrated development environment, it actually simulates the memory of your computer. So there is no leak here. Because Visual Studio takes care of its own memory. So it simulates a memory and does all the debugging in that. But if I close this and run the program from command line, then I'm going to have real memory leak. It's kind of safe in here, OK? So you're not going to, not always. I crashed my computers many times in Visual Studio because of memory leak. But yeah. So anyway, so now what I need to do over here, I need to be able to free the memories of the person. And how do I free the memory of the person? I'm going to say delete. Because I created it with square brackets, I deleted the square brackets. I'm going to say p.name, right? And now this is the time that I will set it to null. Because I don't know if it's going to be reused or not. See, I'm not going to delete it and see what happens. In here, I'm going to say free p. OK? Now I'm going to say display p again. See what happens. Because I didn't delete it, the address is still there. And because the address is given back to operating system, it started using it immediately and put some garbage in there. So it says garbage is 50 years old. It didn't wipe out anything. So now what I need to do, if I actually follow the rule that I said and I run it, Now it's going to say no data in person. So that's why you always set it to not after for now until you find out how things work. Are we okay down to this point? All right, down to this point, life is beautiful. I'm doing everything nicely, and everything is good. So A, B, C, D. And what is in D? I'm going to say over here, init with value. Next would be, I want to be able to add to the name. So it's Fred. I want to make it Fred Soleil. I want to concatenate something to it. How do I do that? So to do that, you must do, what do you need to do? Yeah, exactly. I just want to find a PowerPoint for it. Before I do it, I'm going to PowerPoint it to show it to you. Oh, wrong. One more time. There you go. So how do we resize the memory? So when you resize the memory, you already have data, and you know what the size is. We don't need to know what the size is. Why? You don't answer anymore. Why in that name thingy, person thing, I don't need to know what the size is? No. Because it's dynamic, we need its size. This is dynamic. Why I didn't need to have a size in that person thing? You can always change the size. We're going to have it with the size over here. So let me finish this, and then we're going to go back. Think about it. Why I don't need to keep the size in the person. But let's first do this. So when we do dynamic memory allocation, you have a pointer pointing to a dynamic piece of memory, and you have to always keep track of the size, because otherwise you don't know how big it is. It's just an array, right? You always have to keep track of the size. We don't need it in person. We need to know why. Now you want to resize it. You want to make it bigger. So you get a temporary pointer, and you see what is the new size that you need, the bigger one. And you allocate that much, keeping track of what the size is. Then you copy everything from the old one to the new one. So you bring all the old data from the old memory into the new memory. And then after that, you don't need the old memory anymore. You delete it. So you delete the M data. Now that the M data is deleted, you don't have it anymore. You update the size, because now you have 14. It's not 7 anymore. Then what you do, you make the data that is pointing to garbage now to point where temp is pointing. Now data is pointing in here, right? And when the process is done, because temp is a local variable inside that function, temp will be gone. And what will be left will be your data and new size. And the computer doesn't know the difference. It's just bigger. And we know what the size is. Now, can anybody tell me why I do not need the size in here? That's right. No. Did you already get 1% from me? No? So 1% for midterm. Because we applied another mechanism, which is null termination. We can always count and see what is the size. We said how the things are designed, you count until you hit the null. Because I can count, I don't keep. One of the rules of computation is that What you can calculate and count, you never keep. That's waste of storage, right? Again, until you know how to break the rules. Okay? Until the time comes and the data is so big that counting is take too long, then it's a good idea to actually keep it. Okay, so we need to know. Now, let's do resizing. So I want to add something to the name, so I'm going to call it over here void add to name. Person, P, and then what am I going to do over here? I want to add const character pointer name. So I want to add this name to the other name. So the first step was to allocate enough memory that can keep both of them. Right? So what do? I'm going to have character pointer temp set to new strlen of mname, the name that I currently have. Okay, plus strlen of the name that I want to add plus one that is null. And obviously I have to say a character. Oh, it's not mname, it's pm name. Right? So that's the first thing I do. Now temp has space for both of them, right? What else? What I'm going to do? Now I'm going to say str copy into temp so I'm going to copy the m name into the temp. So now temp at the beginning of it has the name, right? Now I'm going to concatenate the second one to the back of it. Now I'm going to say strcat to the end of temp, the name. Now temp contains both the name and the last name. Everything is done. I don't need the old one anymore. Now I'm going to say free. No, I'm not going to say free. I'm going to say delete. I wanted to say free, reuse my code, but forget it. p.mname. So I'm going to delete the mname. Should we set it to null? No, because I'm just going to set it to temp right now. I don't need to. But if you're not sure, set it. If you're not sure, do it. Set it to null. I know that immediately I'm going to say p.mname points where temp is pointing, right? And then I'm done. Finished. Now it's going to add the value to it. Many people, many students, even seasoned programmers, by mistake delete the temp at the end. They say, we allocated, I have to delete it. No, you don't. Be careful. Many people do that, not to have memory leak. But if you do that, you just destroy what you accomplished 2 seconds ago. Okay, so make sure you don't do that. Now in here, I can actually say something like, so instead of freeing over here, I'm going to say add to name in P, and I'm going to put like that. Now I'm going to say free P at the end. And that, ladies and gentlemen, is memory resizing. Are we okay? Walk through this. Okay? How do you walk through dynamic memory allocation? How do you walk through dynamic memory allocation? I told you last time. Yes, you use different. First, you go to dollar store, get one of those 4 colored things, and then you draw. Draw everything you see over there on the paper. I know it's against your religion to touch the paper. You have to have your notebooks and the cell phones and the tablets. Draw. Extremely important. Draw. Be manual. Please. I know I sound like an old dinosaur telling you that, but do it if you want to commit it to your memory and understand how things work. When you come to a quiz, especially a programming quiz, come with a blank paper. You're allowed to bring your paper and a pen so you can draw stuff when you're programming. Not to pass notes to your friend, though. Remember that. Okay. Are we good? Yes. What do I do? The target of a pointer. Remember that. So pointer has an address in it, right? That address is pointing to a piece of memory that is rented to us, and we are using it. Now we rented a bigger space. We don't need the old one, so we have to give it back to the operating system. So I say, hey, operating system, delete this address, which means it goes to where the pointer is pointing and gives back what we rented to the operating system, and then sets the new address to the newly rented place. Now we can move to a bigger place. Does that make sense? Okay. That's another common mistake, that people think when they delete a pointer, the pointer is being deleted. No. Where pointer is pointing is being deleted. The target of the pointer, what the address is, that's going to be deleted. Are we good? Are we okay? Oops. It was logging me off, sorry. Questions? Suggestions? Objections? That sucks. What I just wrote, it sucks. It's not object-oriented. What did we say when we were talking about object orientation? We said we encapsulate things. We put the data and the behavior related to that data inside the class, right? I'm saying init p, what if you forget to initialize it? I'm saying free, what if you forget to free it? We don't want that. So all these things are supposed to be done automatically by the person itself. Struct number int value void add to number. Then I put over here number reference n and integer value. Then I'm going to say n dot m value plus equal value. Of course, I need to initialize it, right? So void init number reference n, and that sets n dot m value to 0. Right? This is what we did in that dynamic memory allocation thingy, right? And now in here, I'm going to say number num, and I'm going to say init num, and that's a new version for it. Init num, and then I'm going to say add to number, and I'm going to say num and 10, and so on and so forth. And then I'm going to display the number. Number constant. Come on, you can do it. There we go. Okay, so now in here I can say display num. We run the program. There is no, seriously? Stupid compiler. Where? Oh, here? Okay. Thank you. We're good? Are we okay with this? Questions? Now, C++ says, because these belong to number, put them inside the number. Oh, actually, before doing that, let me do something. If you know, what does that mean? Now, when we do that, what happens? Attention, attention, Achtung, please, okay? First, let me wipe out this init schminit thingy over here. If you have, got a question. If I write over here integer x, and I have a for loop over here, can I access the x in here? Why? Because I am in an inner scope of main, right? Scopes we talked about. Same thing over here. When the functions are inside the structure, you don't need to pass the structure to it. It is already in there. It has access to it. So I don't need to say init number. All I need to say is set the value to 0. If I want to add to number, I don't need to say number. I'm going to say add to and remove the number and simply make m value to be added to value. If I want to display something, I don't need to mention what am I displaying because it belongs to it. It's inner one, right? And because of this fact, now it's going to actually look like this. Take a look. I'm going to say number, num. Then I'm going to say num.init. It means initialize yourself. Now I'm going to say num.add2, and I'm going to say 200. Add 200 to yourself. Or even 2 is wrong, just add. Right? Now in here, I'm going to say, hey, number, display yourself. Now I can have n1 and n2. And n2 is a completely different thing. Each one, when I say n1 init yourself, n1 will init itself, not n2. Right? If I told you, answer the question, he's going to answer, not her. Each person knows he has a method called answer, and she has a method called answer. When I invoked his answer, he will answer it. That's object-oriented. There's no mystery behind it. It's very simple and straightforward and logical. And if I run this, you will see that as soon as I go through it step by step, you will see that n1 and n2 are created with some garbage values in it, hopefully. You see there's garbage in it. So let me actually show you. If I say over here n1 display, n2 display. So let's run it again. And move this to left. Oh, actually, first, let's run it first. So let's execute it. There we go. All right, let's put this one at left, this one at right. And now let's go through it. So I'll go, I'm pressing F10. So it comes over here, and as you see, now I'm pressing F11 to go inside. So it goes in and displays the value, some garbage. And now it goes to N2, displays the value. Strangely, two equal garbages. Okay? Now it comes over here, it says initialize. It goes to the first one and sets that garbage to 0. And then adds 200 to that value, which is 0. Now it's going to say display it. Because it's already set it to 200, 200 will be displayed. Now it goes to the next one. Initializes the second one, adds the value to the second one, and displays the second one, and 3000 is displayed. Each one knows what to deal with. Are we okay with this? Are we okay 1? Are we okay 2? We're okay, right? Now, another good thing that we can do, there's somebody may do something like this. N2 dot m value plus equal 5000. And when you run the program, you see that the value is 8,000. And you say, what the heck? I just added 3,000. Why it's 5,000? This is pickpocketing. This is when I told you when we go to Tim Hortons. Did I tell you Tim Hortons coffee? No? I didn't tell you that. I told you that. That's an example for encapsulation. No? Okay, line up. Tim Hortons, I'm going with him. I didn't bring my wallet. I want to buy coffee. I asked him, remember? And I said, remember that? That's just what happened. I can tell add 3,000, or I can do it myself. This is illegal. You're not supposed to do that. We can prevent it. How? Done. It means no one is allowed to touch this but me. Therefore, now we have an error. That's encapsulation. And structures and classes are identical things. But the thing is that structures are public by default because they are used for records and stuff. Classes are private by default. So mostly you will see this. So instead of this, you see people do this. They write over here class, so they don't have to write private over here anymore because classes are private by default. Now, this is private except these. Okay, now if I compile and run this, it's going to tell me, hey, what are you doing over here? You are having, this thing is inaccessible. You see? Number yada yada declared in line 22 is inaccessible. You're not supposed to touch it. Don't put your hand in my pocket, in other words. Right? And that's the nature of encapsulation. Private properties are held private, and the rest are public. Are we okay? So 11:35 class ends. Give you 5 minutes, okay? Go freshen up, come do your quiz, and then if we have time, we're going to continue with this. 5 minutes, go. Thank you. So I put all the functions inside the person to make the person encapsulated too, and I am going to remove all the references to person in the functions because now they are member functions. Now member functions, functions that are member of a class are called member functions in C++. In object orientation, member functions are called methods. Method. So you have methods, you have attributes. Now my person is encapsulated and I do not need to pass it to functions. I simply tell to the person to initialize yourself to a name and age. Now I'm going to ask the person to display yourself. Add the person to add to your name, whatever I want to add, and say display yourself and free yourself. So essentially, that's what they are. And I run it, run forest run, and it works the exact same way. Absolutely no difference, right? Now, at last 2 minutes, I'm going to give you another information. When I'm actually writing this code, it's very possible that I forget to initialize the person. And it's very possible that I may forget to free the information of the person. If that is the case, it's going to be disastrous. I wish there was some mechanism where I could execute few things as soon as a person is created, and I could clean up right before the person is going out of scope and dying. These two are special procedures. They are not functions. These are special procedures. These procedures all carry the same name as the class. Again, I repeat, these are not functions. You cannot call them. So you want to initialize a person. I am doing it exactly as I've done. And I'll take the initialization to the private section, which means nobody can do initialization or free the memory. But it will be done automatically. How? I create what we call a constructor. A constructor is a function-like procedure that carries the same name as the class, and it doesn't have a return type. The one that I didn't want to pass anything calls the init. And now I'm going to create a person with a constant character pointer name and a size th. And I call the init with name and age in it. And for free, it's what we call a destructor. A destructor or deconstructor is a procedure that is called right before he's dying automatically. So, and it's exactly like a constructor, but start with the wiggly thingy at the beginning, which is tilde. So tilde person, and it never has an argument or a return statement. And in here, I'm going to say free. Now, when I create a person with name Fred and 50, this is what happens. Take a look. When I run the program, I'm saying create a person. As soon as I say create a person, it says create a person with 2 arguments, and therefore this is called automatically and initializes the person. And everything else happens. And as soon as it dies, it automatically calls the destructor and frees everything. Done. Now I have an object-oriented person. This is really object-oriented. It constructs itself, it destroys itself, it does its own business, and nobody can touch its private property. We just covered 2 weeks. So the next days you're coming in, example after example. Literally 2 weeks. Member functions and privacy, construction and destruction. It's as simple as that. Okay? So we're going to, and especially for dynamic memory allocation, these constructors and destructors are absolute necessity, because those are the ones that leak and you forget things. With automation of construction and destruction, you have no worries. Everything happens automatically. So next day you are coming, we're going to create different type of examples of all these things, go through it over and over and over and over. Remember, and I'm going to shout, you're going to get scared of what I'm going to say. Constructors and destructors are not functions. You cannot call them. You can call a function. A constructor and destructor cannot be called manually. If you call them manually, something else happens. It's not calling. Careful. They look like functions. They are not. You are never allowed to call them. They should be called automatically when an object is created and when the object gets destroyed. Capiche? Are we good? Have a beautiful day.
Did you pause it?
I'm pausing it now.